Hi guys, this is Calculus video 6-4 for Wednesday, February 8th. The corresponding homework is page 7, number 3, just one problem, similar to this. We're going to find the volume of the solid whose base is bounded by the circle, by that circle there. This is the circle with center 0, 0, and radius 3. Okay, so there's that circle. And the cross sections perpendicular to the base of this, or the cross sections are perpendicular to the x-axis, and they are squares. Okay, then we're going to do semicircles, and then we'll do equilateral triangle cross sections. So let me give you an example of what this looks like first. So here it is. This is what the solid would look like. Okay, so something like this. Okay. Right, so that's kind of what the solid would look like. And if I was all the way on the side. Okay, but imagine infinitely many of those. Infinitely many of those just jutting out of the paper. Okay, so there's that. So that would be with squares. And remember, the way that you do these is you set up this chart. Okay, so, let me write the equation. So this is x squared plus y squared equals 9. All right, so I'm going to ask myself, perpendicular to what? I'm going to draw a picture of a cross section, and I'm going to find its area. So since they want us to have our cross sections perpendicular to the x-axis, that means everything is going to be in terms of x. Remember, in terms of x means that y is solved for. Okay, so before I move on, let me just solve for y. I would subtract x squared from both sides, and then I'd have to take the square root, so I get that y equals plus or minus radical 9 minus x squared. Okay, so the top half of the circle, that's going to be, that has positive y value, so that'll be y equals the positive one. And then the lower half of the circle, that's going to be the negative. That's where the y values are negative, so that'll be the negative one. Okay, so now cross sections. So I'm gonna, just a second. Okay, so cross sections. Let me look at this. Actually, which one is this? Right. So I'll do. So let's let this represent the base of that cross section. Okay, so that's the base of this cross section right here. Okay, that's jutting out of the paper. And the way that I would find the length of it is I would go top minus bottom. All right, now I'm going to draw this very same line, a small version of it over here. I'm just going to lay out the base of it. I'll find the length of that green line. Remember, when I do this, this green line is the same as that green line. Okay, I'm just transferring it over here into my chart. And so if I do top minus bottom, well, the top function is radical 9 minus x squared. I lost my pen. Here we go. Radical 9 minus x squared minus the bottom function is negative radical 9 minus x squared. So we're subtracting a negative, so that's plus radical 9 minus x squared. And guys, you can simplify this. There's two of those. So this is 2 radical 9 minus x squared. Okay? So that's the length of the base of this square. But now we still need its height. All right, so let me complete my cross section. It's a square, so everything's congruent. The area of a square is base times height. And by the way, guys, you always want to ask yourself, like, do I have to change cross sections? Like, are the top and bottom functions ever changing? The answer is no to this situation. So the area equals, since the base and height are the same, I'm just going to have the same thing times itself. So 2 radical 9 minus x squared. All right, so that's the area of that. So the volume of that solid that I tried to show you a visual for at the beginning is going to be the integral. Okay, we're dealing in x. So from x equals what? What is the lowest x value here? Well, the radius of this circle was 3. Okay, so the lowest x is -3, the highest x is 3. So the volume equals the integral from x equals -3 to +3 dx, and what goes inside of here is the area of the cross section. So each cross section is represented by, each cross section has this area. 2 radical 9 minus x squared. Okay, and I'm just going to plug that into my calculator. I wish I did this earlier to save time. Okay, I'm plugging it into my calculator right now off to the side. 2 radical 9 minus x squared. And I got 144. 144. That's a nice number. Huh. Okay. So now we're going to do semicircles. Okay, so the next thing that we're going to do is semicircles. So let me show you an example of what that will look like. Okay, so I have these jutting out of the paper. So everything is the same. Okay, perpendicular to the x-axis, everything is the same, except this time the solid is going to look like this. So imagine infinitely many of those. Okay, so infinitely many of those. Sorry if I'm making you dizzy. And I'm trying to get like a good side view. Okay, so, but there's that. Okay, so the only thing that is going to change about our chart is the cross sections. All right, so I'm going to set up a new chart, and it's going to be still perpendicular to cross section and area. Okay, so again, we're perpendicular to the x-axis, so still everything is in terms of x. And so I'm still, so now this is my cross section. I'll use that same green line, okay? So the length, notice the length of this base of this semicircle it's going to be the same as the base of the square. All right, I'm using the same green line. So the cross section is, all right, I'm going to lay out the base of it right there. Okay, top minus bottom, I'm going to get the same thing that I got before. So 2 radical 9 minus x squared. And then let me just complete the semicircle, just like that. Right? And then the area of this is, the area of a full circle would be pi r squared, but this is a semicircle, so we have to divide it by 2. So the area is going to be pi. Now, what is the radius of this? Okay, this full diameter is 2 radical 9 minus x squared. So the radius is just going to be half that. So if you cut that in half, you just get radical 9 minus x squared. And then we divide that by 2. So that's the area of that. So the volume is going to be the integral from x equals -3 all the way up to 3 and then pi, and then radical 9 minus x squared squared all over 2 dx. Okay, and let's see what we get here. Okay, so math 9. Math 9. -3 to 3 pi over 2 9 minus x squared and I got 56.5487. Geez, a lot smaller, less than half of the one with the squares. Okay, so that would be a solid with less volume. And then finally, guys, equilateral triangles. I didn't do any little cutouts for this, so you just have to try to imagine it. Here I have a little equilateral triangle that's, or not equilateral, but I have a little triangle just lying around. So those, they'd be shooting up like this all the way across. And you'd have a different shape. So same process, perpendicular to, go ahead of me guys if you got this, or speed it up. Cross section area. Okay, so the x-axis, the cross section, we're using that same green line as the base of the equilateral triangle. Okay, so it's gonna be this. Alrighty, and it's still 2 radical 9 minus x squared. Alrighty, now the equilateral triangle, its height is going to be shooting up right from the midpoint. Okay, so that's going to be the height of it. And then I'll just go like that, and those are the same. Now, here's the tricky thing, guys. We've got to use, okay, so now this side here is also 2 radical 9 minus x squared. We've got to use the Pythagorean theorem to try to find this height here, okay? Now, if this whole thing is 2 radical 9 minus x squared, then that means that this little piece has to be half of it. Okay, so that little piece has to be half of this. And then this will be the hypotenuse of this right triangle that I'm about to use the Pythagorean theorem on. And then, so I'm trying to find this here. So, off to the side, I will say, I'll call this y or something, okay, because no, y is already being used. Okay, never, I'll call this h for height. Okay, so there's h for the height of it. And so Pythagorean theorem, I've got h squared plus radical 9 minus x squared squared, okay, that's just this part right there, is equal to 2 radical 9 minus x squared squared, okay? So h squared plus 9 minus x squared is equal to 4 times 9 minus x squared. So then I've got h squared plus 9 minus x squared equals 36 minus 4x squared. So h squared is equal to, I'm going to add x squared to both sides and subtract 9 from both sides. So I end up with 27, right? Minus 3x squared. Okay. So then h is equal to plus or minus radical 27 minus 3x squared. Okay, and it's just going to be plus, guys, because it's shooting out of the paper. So that would just have a positive height. Okay, so now the area of this, an area of a triangle is 1/2 base times height. So the area is equal to 1/2. The base is that green length, that whole green length. So 2 radical 9 minus x squared. And then times the height we just found off to the side is radical 27 minus 3x squared. Okay, so I've just got to add up all those areas. So this last volume is the integral from x equals negative 3 all the way up to 3. That 1/2 and that 2 actually cancel, so I won't even bother. So this is radical 9 minus x squared times radical 27 minus 3x squared dx. And in my calculator, I'm just going to compute this, but the video is basically done. So if you want to move ahead, do it yourself and stop the video, that's fine. Don't forget the homework. Math 9, from negative 3 up to 3, radical 9 minus x squared. 27 minus 3x squared. And I got 62.3538. Okay, so the one with semicircles had the smallest volume, and the one with the squares had the largest one. Okay, guys, have a great day. Don't forget the homework. If you're still with me, it's page 7, number 3, and I'll talk to you soon. Bye-bye.